Scientists from the University of Oxford have uncovered important evidence for the origins of water on Earth through the study of a rare meteorite. The discovery challenges long-held views and opens up new insights into the formation of our planet. Scientists have long debated where the water that covers 2/3 of Earth's surface came from. One of the dominant theories is that it came from a water-rich asteroid that slammed into Earth in the first 100 million years after its formation. However, new research from the University of Oxford suggests that Earth actually had the building blocks of water, hydrogen, from the very beginning of its formation.
The team studied a rare type of meteorite called an enstatite chondrite, which is believed to be very similar to the material that formed Earth 4.55 billion years ago. By examining the meteorite, they found that the hydrogen, a key component in the formation of water, actually came from within the meteorite itself, rather than from environmental contamination. This suggests that the earliest building blocks of Earth likely already contained large amounts of hydrogen. Meteorite LAR 12252 study. Diving deep into structure with X-ray technology, the study focused on a meteorite called LAR 12252 found in Antarctica. The team used a sophisticated technique called X-ray absorption near-edge structure, XANS, spectroscopy carried out at the Diamond Light Source, a high-energy X-ray facility in Harwell, Oxfordshire. Previously, the French team had detected traces of hydrogen in the organic and non-crystalline material of the meteorite. However, they were not sure whether the hydrogen came from the meteorite or was contaminated from Earth. This is where the Oxford team took things a step further. They suspect that a significant amount of the hydrogen may be bound to the element sulfur, which is abundant in meteorites. By shining X-rays on the sample, they looked for sulfur compounds that carry hydrogen. Surprising discovery of hydrogen sulfide in meteorite matrix. While analyzing the exterior of small spherical structures in meteorites called chondrules, researchers unexpectedly discovered that the meteorite's matrix, a fine, submicrometer-sized material, is rich in hydrogen sulfide. According to their measurements, the hydrogen content in this matrix was 5 times higher than in the previously non-crystalline part. In contrast, in parts of the meteorite that showed cracks or signs of contamination from the Earth's environment, such as rust, hydrogen content was almost non-existent. This strengthens the conclusion that the hydrogen in the form of hydrogen sulfide came from the meteorite itself, not from Earth. This finding indicates that the early Earth's enstatite-like chondrites already contained a lot of hydrogen from the very beginning of its formation. Thus, Earth did not have to wait for a water-rich asteroid to arrive to form its oceans and atmosphere. Water is a natural part of Earth. Tom Barrett, a PhD student in the Department of Earth Sciences at the University of Oxford who led the study, said, "We were very surprised when the analysis showed that the samples contained hydrogen sulfide, and not where we expected it to be, as it was unlikely to have come from contamination." This research provides important evidence that water on Earth is a natural part of the planet's building blocks. Co-author Associate Professor James Bryson added, "The big question for planetary scientists is how Earth got to be the way it is. We now believe that the Earth's building blocks are much richer in hydrogen than previously thought." This finding supports the idea that water on Earth was a natural process, rather than just a chance event caused by an asteroid shower.